Hello, everybody. So I'm going to tell you about the second half of these pictures. Most of this conference is about getting to that first picture on the left. It's about using technologies like Spark in order to tackle big data and to really transform the world with this amazing new stuff that you can do with these new technologies and this new big data challenge, right? But once you've designed your algorithms and once you've written your software and so forth, you've got to put it in production. And if I can use an analogy from the car world, you've designed a new car. Now you've got to stamp out 1 million of those. And so what you're going to do is you're going to take your shiny little thing that's way down there in the middle and you're going to build a giant factory around it. And most of building that factory has very little to do with what you did in order to design the car. And so you're going to face a bunch of things that are very different than what you're doing with Spark so far. For example, you're going to face the productionalities. Scalability. You're now suddenly going to be running many jobs, thousands, perhaps millions of jobs, and you're going to be running them day in and day out. You're going to have to keep track of them and so forth, all the relations between them. You're going to have to make all of this stuff highly available. When it's in production, there's no excuses for not delivering the stuff on time, and you're going to have to design that in from the beginning. You're going to have to worry about maintainability. When Spark 2.0, or rather when Spark 3.0 comes out, you're going to have to update your systems, and you're going to have to update them in place. It's going to be like changing the tires on your car while running it. You're going to have to deal with security patches that you're going to have to put in place almost immediately. Backups, there's a bunch of stuff to do to run this in production. And by the way, it's got to be evolvable. So you're going to have to be able to take something and a year later have a new person come and modify that and still make sure that everything that ran the old way still runs the same way. So these are your challenges. You're also going to face the fact that when you were designing your system, you might have been running on test data, and so you had data, say, about Mickey Mouse, who lives on Main Street in Disneyland, USA. Now suddenly you're going to have personally identifying information. You're going to have credit card information and things like that, and you're going to have a lot of it. And you're going to have to maintain it, manage it, so that you can't get hacked and have 100 million credit card numbers disappear. And you're going to have to make sure that John Doe only gets to see the data for John Doe and not for Jeff Smith, for example. So all of that's got to be built in, all the access management, all that stuff. You're also going to have to deal with auditability and reproducibility. Imagine you're going to make money off this thing that you've built. So you're going to meter the usage of your customers. And then you're going to compute bills from those metering records, and you're going to send them out. And I guarantee you some of your customers are going to dispute those bills. Now you're going to have to go back and say, well, what did you actually use? I have to have an audit log of the metering records so that I can actually demonstrate what you did. And I've got to be able to reproducibly show you how I calculated that bill and the various parts of it so that we can then come to a resolution on this. And again, this has to be built into your infrastructure. Spark is about enabling you to look at what I'll call sweepingly algorithmic efficiency. How you lay out your data, what the order of your algorithms are, stuff like that, right? Once you've got all that running, now you're going to face what I'm going to call mundane efficiency. Things like the fact that constants matter, and that, for example, the difference between storing data in S3 and storing it in Glacier can be a factor of several. And when you're talking about 2 to 4x on dollars, that matters. Now, this had nothing to do with your big data. This had to do with remembering what data is cold and putting it someplace cheap, because you're going to want to keep your data around for some time, and it's going to be somewhere hidden. The cold data is going to be hidden somewhere in that stack of boxes that I show there metaphorically, and you've got to remember which of the boxes are the ones you want to throw away and which ones you put in cold storage and so forth. Same thing applies to your jobs. You're going to be running millions of these jobs. Some of them are going to fail. Some of them are going to fail in a way to where you can't easily tell. They'll be your zombies, and they'll be wandering around sucking up dollars while they run. You've got to find them, and you've got to get rid of them. So those are your challenges. You're also going to find that as you go into production, you're going to end up with a different type of user. When you started out, you're focusing on pioneers, and the pioneers want control. They want to be able to experiment with their algorithms, to experiment with their software. They're still putting their mind around the applications area they're working on. But as this stuff goes into production, it's going to be used more and more by people whose skills are in a different area. It might be a biologist who's the world-leading genomicist, or it might be an astronomer, and they don't have the time or the interest or the skills really to go tune your big data systems. They just want to use it. The other thing you're going to find out is that you'll put something out and you'll put it in production and you will be amazed at how people use it. If I were to use another car analogy, you may have designed a Ferrari, the Spark equivalent of a Ferrari that runs at 250 miles an hour around a track. And what you're going to discover is somebody is going to use that and then say, well, that's really cool. I'm going to go take it off-roading. Now, why would they do that? Well, they're going to do it because the Ferrari was available and because they've learned how to drive a Ferrari. And so they're going to try and take it offline. They're going to try and take it out in the mud. And you are going to have to survive that, because if you're in production and if you're, say, in a multi-tenant system, you don't get to just say, well, sorry, you stuck your Ferrari in the mud. Your Ferrari is being used by other people as well. Plus, the experience has got to be that it works. So you're going to either make it easy for them to get a Jeep under the covers, or you're going to figure out how to allow the Ferrari to be used off-road and still get the result. Because at the end of the day, your customer is just going to care about getting the result. And by the way, once you've enabled them to go off-road, the next thing they're going to do is they're going to hook a boat to that Ferrari and try and tow that, right? So you've got to design your systems to be able to tolerate uses you never expected that might blow you out of the water, and you still have to give a good customer experience. Well, let's start talking about mechanisms that might help you for that. The primary thing you've got to do is automate. Scale is going to force you to get rid of everything manual. If I were to use my car analogy again, imagine that your application consists of enabling the morning commute. If this were, say, finances, to take this back to the data world, imagine a financial institution that's got to compute an overnight risk portfolio for every one of their customers. So they're going to run this stuff, and that's going to be the equivalent of running each one of those cars on that freeway. And you are going to have to be able to essentially instantiate every night one of those cars for each of those million cars out there. They're each going to be different. They are different, different colors. They have different passengers in there. They've been customized in different ways. They go from different places to different end destination. And if you don't automate that, if you don't use, say, something like CloudFormation if you're in AWS, then you are going to spend too much time on that, right? So everything is automated. You're running this now. Things will go wrong. A car will crash, to use my analogy again. Now, what you don't want to do is go scan your freeway in order to go find where the crash happened. What you really need is something where you've designed the system so that the crashed car can call out for help. In the cloud space, that would be, for example, having your systems use something like CloudWatch events or CloudWatch alerts and metrics in order to signal they need help. But you're going to have to automate even more, because if you have humans respond to those things, it still won't be enough when you get to true scale. You're going to need to automate the response, and you're going to need to do things like run Lambda functions and so forth in response to those alerts in order to automate dealing with this freeway that you're running. So automation is everything. As I said, it's got to be highly available, and what everybody learns in school is how to deal with single points of failure. I'm going to switch to a different type of analogy now of houses. Imagine you're running your business, and you're running it out of the building, and you've been really smart, and you've decided, I'm going to go buy a second house in another town in order to be able to withstand a tornado coming along and destroying my house. I'm now single point fault tolerant, right? When you're running in production, what you're going to find is at some point, the tornado is going to come along and destroy your entire town. A data center will go down, or something like that, right? Now your algorithm, now what you're going to discover is that everybody in town who has bought a house in another town is going to be doing the same thing. They're going to be trying to go over to that house in the other town. And they're probably going to go by the storage lockers in order to get the data that they need in order to reconstitute their business in the other place. And there's going to be a traffic jam at the storage locker and on the highways out of town. And it's not going to work. And so you're going to have to start thinking about things like, for example, what we call work-conserving recovery algorithms. Anytime your recovery system requires more work on any part of your infrastructure, what you've done is set up a situation where under a large-scale event, you're enabling your recovery system to do a DDoS attack against that part of the infrastructure. So you're going to have to design your systems to avoid that. Now, an even worse thing can happen when you realize that you're running all this stuff asynchronously a lot of the time. You've got all of these workflows running all over the place, all the time, and sometime in the last week, something went wrong. So I've given an example here on the slide. Imagine you've got a workflow that's got 3 activities. That first one has a bunch of sub-steps. The second and the third activity depend on the output of it. And step 2A down there goes bad. But it doesn't go bad in a way that stops everything. It merely, say, corrupts some data. And everything else keeps running. And now it's over. And now the question is, okay, is everything okay? If this thing spit out the number 41, was that the right answer, or should it have been 42? And if it's not 42, if you decide that 42 is the right answer, how do you go figure out what went wrong and how to correct it? You're going to basically have to build the breadcrumb infrastructure that allows you to know what all the inputs were that you calculate on each workflow and what results you should be getting out of it, how to audit those things, and then essentially correct it. You're essentially going to end up starting to use the techniques that the financial community has used for things like accounting. You'll have ledgers of your input. You'll have data amendments. This is a key thing that a lot of people don't think about. Data will inevitably go wrong. You'll inevitably even find that your input sources, say your sensors and things, have to be corrected. And so after the fact, you're going to have to correct that and recalculate things. If you don't design it right, if you don't put in, say, an inversion of control-oriented infrastructure so that you can go back and recompute exactly step 2A instead of recomputing the entire thing and spending all the money that entails, then you're not going to be happy with this in production. You're going to have to deal with security and access management. In production, this is kind of like managing a big city. And you know that somewhere in that big city, you've got a burglar who's trying to break in to someplace. And structure is going to help you there because you can't just go wandering around the city scanning things. You're going to need to, and if it's the cloud, do things like, for example, hide your neighborhoods from the burglars by, say, putting them in a virtual private cloud setting. You're going to have to manage access to your neighborhood by, say, doing something like defining users and roles for who can get into them and what they can do once they're in that neighborhood. You're going to have things like CloudTrail in order to have a log of exactly what happens so that when a breakup happens, you really do understand and can go back and figure out what went wrong. You're going to need configuration that describes what things should look like. And you're going to need automated response against things like Lambda functions and so forth in order to be able to not have a human being have to deal with every crime that happens in your city. So these are all the things you're going to have to do. And if you've probably all been taught security has to be put in the beginning or it's going to be really hard to retrofit. That's true for all of this. It's true for security. It's true for auditability and reproducibility. These are all the things you need to do in production. Now, if I get back to mundane efficiency, really what most of that is about is figuring out how to be smart about your usage. And what that means is taking advantage of things like usage reports, billing alerts, cost explorers, lifecycle management. There's a bunch of things that the cloud can provide you. If you take advantage of them, life will get a lot easier. If you don't, you're going to end up building all this stuff yourself. And as I said before, you're going to end up in a multi-tenant situation because once you're in production, cost reduction is going to be relentless. No matter how cheap you get, no matter how much you drive the price down on your product, you're going to be asked to do more next year. And that's going to force you into doing things like multi-tenant solutions. Now, the good news is clouds from day one are aimed at that, right? Resource management, running virtual machines, multiplexed on physical machines, that's all what the cloud is about. But there's a whole nother level of this stuff when you start talking about how do I manage access between accounts. Imagine I have this wonderful multi-tenant machine learning system. To get the input data set to it from a particular customer, I'm going to have access to their S3 bucket, say, where they've got their stuff. And I'm going to have to be able to put my output to theirs as well. So I've got to control the access between that without opening it up too much. So I have to do things like that in order to manage that. That is the additional work I have to do, which I'm calling mundane efficiency, because again, it's got nothing to do with your big data. So as I said before, you're going to end up with a different type of user. You're really going to have to support all of the types that I've shown here, from the pioneers at the very beginning to the small settlements that start to the big cities that are going to end up being your end production environment. And what this means, and I'm going to go through two examples to illustrate what the challenges of this are. One is the fact that as you go from the left to the right there, you're going increasingly from a world where your customers say, let me tell you exactly what I want you to do it this way, to just do it for me. And we see this, an example of what this does to your interfaces is, say, with Kinesis, which is a streaming data processing platform that AWS has that's kind of like streaming Spark. Now, the first version we built of that was very much aimed at the pioneers, where there were lots of knobs to control, and you had notions of sharding, and you had notions of being able to write item-potent map functions and so forth. And we put that out, and we thought that our customer feedback was going to consist of, well, that's great, but can you give me like auto-sharding and automatic heat management and so forth? What really happened is we found out that 90% of our market was people who said, you know, I really don't understand even what this EC2 thing is. And what I just want is, can't you just get my data from my sensors into S3 or into my Redshift data warehouse and not bother me with anything else? And so we ended up building a product called Firehose that did just that. That was 10x our market of the first one. Now, of course, what happens is once they get that, they say, well, could I do a data transformation on that? Can I just give you a little snippet of code that will say modify each record? And once they get that, of course, they're going to go farther. And we saw examples of where that goes with what Matej was talking about, with making it easy to do these kinds of streaming applications and just focus on the business logic. What we're seeing in general is a trend toward what's called serverless computing, where people say, I really don't want to have to deal with the underlying notions of clusters or virtual machines or even Docker containers or anything like that. I just want to hand you the business logic. Now, we're not going to be at a point where that's the only way to compute for quite a while, because for a lot of things, you still have to put in the efficiency. If you notice from Jeff Dean's talk, they're still writing in C++ because they need that low-level efficiency. And there's still going to be a lot of customers that need to be able to do that low level of control. You're going to have to support all of them. The other thing you're going to have to support is integrating with the rest of the world when you're in production. As was mentioned at the beginning by Matej, there's a lot of things now coming into Spark that let you sort of go take things from a streaming source and put them, say, into MySQL and so forth. Lots of ETL-like things. Well, if you're familiar with ETL, it's actually a fairly complicated industry, and there's a lot of complexity to it. And even once you've got that, there's more details that you really didn't want to have a think about. For example, how do you get petabytes of data from an on-premise site into the cloud? The cloud can help you on some of those things. You can get like direct connect connections that cut the cost down, but even then it may not be enough. And so in fact, you end up doing things like what the Snowball product is we have, where we take advantage of what Jim Gray said long ago. What's the most efficient way to get, at the time, a terabyte of data from San Francisco to New York? And the answer is FedEx. And so we have the same thing. We now have a product called Snowball that basically ships a container that can store 100 terabytes of data. You load it up in your on-prem data center, you send it to us, and we then unload that into our data centers. So that kind of stuff is what you need in order to be able to have that city going there. You need the complex supply chains and so forth. So to summarize this, to be production ready, you've got to build this stuff in. And you really kind of have to build it in from the beginning. After you've gotten to the eureka point where you've figured out how to do your machine learning and how to do the big data tackling and the big data analysis and everything, and you're at that left picture where you've got all the potential of using this now, you've got to get to the right one. You're going to have to automate everything. You're going to have to make this stuff secure by default, because most people don't really know much about security. You're going to need things like end-to-end change journals and audit logs in order to be able to handle that reproducibility. You're going to be pushed in the direction of serverless event-driven computing. You're going to have to support data amendments, and you're going to have to essentially do all this in the face of relentless cost reduction. The good news is the cloud can help you a lot with that. Spark already runs successfully in AWS. I think it's one of the places where it's got its biggest adoption. It runs on EMR, which is our attempt to make it even easier to use. But really, in the end, you're going to end up integrating with all of the things I've shown you there, because each of the things on there, and there's a bunch I'm not showing, is going to help you deal with that production stuff. The good news is we're trying to make it better, so there'll be less and less muck that you have to deal with as you're focusing on the fun part, which is how to use Spark to tackle big data. That's all I've got to say. Thank you very much for listening.